Good afternoon, everyone, and thank you for joining us for today's webinar, A Practitioner's Guide to Meeting Energy Star 3.0 Thermal Enclosure System Ratings Checklist, Part A. My name is Shanteria Charleston, HAC's RCDI Program and Training Manager, and I will be your host for today's call. If you have not already done so, please ensure that you have access to both the audio and video portion of the webinar. To access the PowerPoint for today's call, please follow the link on your meeting confirmation email. Again, all participants are in listen-only mode, which means your line is muted. However, we are very interested in your questions and feedback, so today to submit a question during the presentation portion of the call, please use the Q&A box that will appear on the lower right-hand side of your screen. At the end of the presentation, all lines will be unmuted to allow for verbal or additional questions. Again, today's webinar is being recorded. Both the recording and the presentation will be available on HAC's website, www.ruralhome.org, shortly following the webinar. I see a lot of familiar names today on the webinar, but for those of you that are not familiar with the Housing Assistance Council, HAC is a national nonprofit organization based in Washington, D.C. that assists local organizations with building affordable homes in rural America. With the mission to improve housing conditions for the rural poor, HAC places a special emphasis on striving to serve the poorest of the poor in the most rural places. HAC emphasizes local solutions, empowerment of the poor, reduced dependency, and self-help strategies. HAC assists with the development of both single and multifamily homes and promotes homeownership for working, low-income rural families through a self-help sweat equity construction method. So, if you're interested in learning more about HAC services or products, HAC has an office near you. If you have any questions or require additional assistance, please contact your nearest HAC regional offices. Those offices are currently being displayed on the screen. Also, please mark your calendar and join us for the following trainings. HAC has several webinars coming up. The Part B to Thermal Enclosures Rating Systems Checklist is going to be next Wednesday, April 15th. We also have an HVAC Systems Quality Installation Checklist, Part A, on April 22nd. Then we have Part B of that checklist taking place on May 8th. HAC is also hosting low-income housing tax credit trainings and introduction on May 13th, as well as management and compliance for low-income housing tax credit on May 27th. We are also hosting a VA Access to Health and Homeless Services webinar taking place on May 26th. Also mark your calendars for the Veterans and Seniors Symposium taking place in Washington, D.C. on May 20th. And so with all that taken care of, now I'd like to welcome today's speaker, Jean Gonzalez. Jean is the Regional Director of HAC's Southwest Regional Office located in Albuquerque, New Mexico. Jean has been working in rural affordable housing for over 30 years. Over the course of his career, he's gained expertise in property management, green housing rehabilitation, and affordable housing. Jean's extensive experience includes subdivision development, single-family housing rehabilitation, Section 202 housing, and Section 514, 516 farm labor projects. For the past 5 years, Jean has provided training and technical assistance in green building, energy conservation, home rating and green rehabilitation for single and multifamily projects. Jean's knowledge of construction has allowed him to teach groups new smart construction along with passive solar, straw bale, and Adobe. And so with that being said, I would like to turn the webinar over to Jean.
All right, thank you, Terry. Hopefully everybody can hear me, and good afternoon. What I'm doing today is basically part one of the checklist. We sent you the checklist and the grader's guide here a while back. What we're going to be doing is looking at the checklist, and I brought the checklist up, and we're only going to be going up through section 4. Since the checklist is so long and we don't want to, bombard you guys with some information, so much information, that it's hard to gather the information. One of the things that I did do with this workshop, with this presentation and webinar, is that I try to develop it so that it's easy to understand. So whether you're the construction supervisor, the HERS rater, the lady, the bookkeeper, the installers, maybe the families if you're doing self-help, we try to make this PowerPoint and this webinar easy enough for everybody to understand. So with that, like I said, it's taking us a lot longer. They only get harder as we go along. The first one here, the thermal enclosure system, I think is about the easiest one. And it's also the most important things that you can do to try to make your unit meet Energy Star, or at least EIC 2009. So again, we'll go ahead and get started with the Rater's Checklist. We did send you this in the past, and we also send you the Energy Star small booklet with all the footnotes and stuff. So I'm using both of those as we do the PowerPoint and the webinar. I'm using those going back and forth. So if you have those available to you, it might be a good idea just to have them around.
Gene?
Yes.
For those folks that don't have it, they can actually download the inspection checklist from right there on their screen. Just simply click on it where it says Files, and then you should be able to download that file.
Okay, great. So let's go ahead and get started. Like I said, hopefully this is easy enough, it's simple enough. We do get into some math, a little bit of formulas, but I'll explain those as we go. And if you have questions in the end, make sure you ask questions. If you want to give me a call at the end, give me a call and we'll discuss maybe your project or whatever it is that you may have questions on. So let's just go ahead and get started. Again, the thing is, first thing you want to do is make sure that you have your address, your zip code. The zip code is going to determine what area you're in. So if you're working in various areas, I know some groups may be working in 4 or 5 different states. So depending on what state you're in and what zip code you're using, that's where it's going to be, where you're going to be able to meet those codes, and those are the codes you're going to have to follow. Again, you're going to have to pick from the very beginning whether you're going to go with a prescriptive path or you're going to go with a performance path. Whether you need to decide this up front, it's not at the time that the inspector comes in or your HERS rater comes in and he's doing an inspection and some of the things are failing that you decide to go maybe to a performance. So you need to pick this up front and you need to stick with it. And then in the end, when you get your checklist, again, prescriptive, it means it says you're going to meet or exceed Energy Star requirements. And we'll talk about those as we go through the whole program and the checklist. A performance path, it says you're going to meet or exceed the 2009 IECC or the International Energy Codes. Again, the 2009, when this was put together and this checklist was put together, 2009 was the one that we were doing at that time. Again, the 2012 I think is coming out now. And then again, they're taking comments on the 2015. So if that's your thing, you need to get in there and make your comments. Again, whether you're using the performance or the prescriptive, you're going to be using the IECC book anyway, okay? So in the very front, you're going to want to pick one of these. Again, if you're going with the prescriptive, again, we're talking you're going to be above Energy Star. So these are some of the things that you can look from the very beginning. I just threw in the windows so you can see the different U values that they use for windows. Again, they changed this from R values to U values. For those of you that are new to U values or are not sure what a U value is, a U value is the coefficient of transmission, okay? So the transmission, so example, the transmission of heat through materials which compose a building's envelope or outer shell. In this particular case, we're talking about the U value of a window, okay? So it seems that the lower the U value has an inverse relationship to the R value. So for an example, a building with material with an R value of R11 converts to a U value of 0.09. So that's 1 over R or 1 over 11 equals 0.09. Very confusing, but it's just the inversion of of an R value to a U value. So this gives you the description of the different areas that you're in. If you're in climate zone, northern climate zone, you're going to want a window with a U value equal to 30.30 or 3. And as far as the solar heat gain, any rating will do. But then you get down in these areas down here, like in southern areas, you got something that's equal or less to a 0.6, and then you want a solar gain of 0.27. So you can see as the windows, as it gets hotter, those windows, you want less solar gain coming through, and you want the U factor to be lower. Same thing on skylights. Most of these skylights are the numbers that you use, equal to or less of 0.55, equal to at least less or 5.7. Down here, when you get to the southern area, 0.70 or 0.7, and a solar gain of 0.30. So as you can see, the windows make a big difference on how this is going to rate on your unit. Again, the pictures to the left, it shows a window that doesn't have the rating system or the U values on the windows. The next one, as you can see, the U values, the heat gain, all this meets the Energy Star and it meets the requirements that it asks for. One thing you need to remember is that these stickers need to stay on the window until the inspector comes in there or your HERS rater comes in. If not, take a picture of it. Make sure you can detail the window with the picture so you can identify and prove that your windows do meet Energy Star. Doors, same thing, just a little bit on doors. R values, U values, 55, 57, 70. Again, the performance path, is pretty much the same. They're a little bit higher. Again, zone 1, you're getting a 0.65. These are the minimums. Again, these are going to be the minimums that you're allowed in order to meet your performance path. Anything less than this, it's not going to meet it. Or higher numbers than this, it's not going to make it. Again, skylights, as you can see, they're pretty much the same. It's only about 10 R values, a little bit different on the bottom there, and a little bit higher for the skylight requirements. Skylight requirements, again, we talk about skylight requirements and U values. A single wall skylight probably has a U value of 1.15. A double wall skylight or a double window, double glazed skylight is going to have a 0.70. So if you're looking for something here that's going to have to be a 0.60, you're going to have to go with a double insulated window or skylight. Again, okay, so that pretty much just lets you know whether you're going prescriptive or performance. Again, one of the things we'll talk about just now is we're talking about insulation, the quality insulation that you want. One of the things that we recommend, or I recommend, is this thing right here on the bottom where it says, knowing the exterior boundary of the house is critical for everyone involved in knowing what barriers of the insulation. One of the important things to do is that I've always done is that if you got a HERS rater that you're working with, or what I call a green reader, I would have them submit your plans to the green reader, have him rate that house off of your plans and your description, work of descriptions. And that rater can actually come back and tell you if you built this house as is for your plans and specs, it will rate at a 64 to a 67, or it'll rate wherever it'll rate. I've done this a couple of times with Passive Solar Adobes, where we send in the plans, get the ratings, and the green rater or the rater comes in and he says, well, if you built this unit as per your plans and specs, your units are going to come in at about a 64, a HERS rating of 64 to 67, and our units came in at 64 and R64. So, you got to work real closely with your raters, and if you do a lot of these in your plans and specs, once you build one and you have your plans and specs ready for that one, you can match it and you can see what you do and what you need to do. So again, insulation, it talks about insulation. It says all walls have to be insulated and so on, and it gives you a breakdown. Again, common insulation are all, our values are here. So if it depends on what area you live and you're looking at your exterior or conditioned area, what are the R values that you're going to need? Some of the R values, there's some high-grade insulation, there's some high-density insulation. on the market now. I think there's a blown-in white fiberglass. I think it comes in at 3.8 or up to 5.2. Wet cellulose, you can get it up to a 3.8. And there's other things that are coming in. The SIP panels, depending on what the thickness of the SIP panel is, it comes in at, if you got a 4-inch or a 6-inch SIP panel, you're coming up to about an R24 in the walls, and that's just with the SIP panel. So depending on what material you're using, what are the R values you're trying to reach on your installation, these are the things. Again, once you get in, whether you're going prescriptive or performance, most of your installation is going to have to meet or exceed that 2009 IECC levels. So either way, you're going to have to meet those levels minimums or a little bit more if you want to meet Energy Star. Again, it talks about Energy Star. You're going to need to meet, you have to be greater or equal to 133% of the needed required insulation. So again, you need to figure that calculation out. I figured it out at one time. It's like adding an R8 to whatever the minimum requirement is for that area. So like in our area, it's an R30 in the attics. If you want to go Energy Star, then you have to go to an R38 minimum. Again, ceiling, walls, floors, and slabs, they all must meet or exceed the IECC levels. I kind of glanced at the 2012 IECC levels. There's not much changes in there as far as insulation. Talks about the corners again and those type of things. But again, you want to achieve that greater or less than 133%. All ceiling and wall and slabs insulation should be installed. Again, depending on what climate zone you're in, climate zone 1 through 4, it's equal to or greater than an R3. Again, an R5 for climate zones 5 to 8. New Mexico, we're using probably anywhere, we're using the blue board on those, so we're going anywhere from 5 to 10 on our values on the slabs. Again, it talks about insulation. These are your walls. Talks about your walls. These are your minimum R values in order to meet 2009 IECC levels. So if you're going to Energy Star, I talked about that a little bit. So with Energy Star in the Zone 1, you're probably looking at an R38. Framed walls, you're looking at an R13, but you're also going to be putting a foam board on the outside, and we'll talk about that in just a little bit. Again, these are your minimum levels depending on what zone you're in. Depends on the amount of insulation you're going to want in your ceilings. You get up into northern United States, you need an R49. For an R49, that means you have to have some attic space in there, because if you're dividing that, even with the high-grade blowing in R5, you're still looking at about 12 inches of insulation that you're going to be blowing in of high-density fiberglass. So you need to allow for that room up in the attic. And one of the words that you need to remember when you're doing attic or any kind of insulation is continuous and continuously, because that's where they get you on that continuously insulated attic. They want that insulation to be the same R value as it is over the side walls as it is in the middle. So in order to get that, you have to go into a different framing, and we'll talk about framing a little bit later on. Okay, we talk about the frame walls. These R13, this is basically just a 2x4 construction. That's about how much insulation you can put into that wall. Again, when you get into Zone 5, Zone 6, it talks about an R20, or you have to have an R13 inside the wall with an R5 minimum continuous insulation on the outside. So again, that's what that means. When you come into an R13 plus an R5, the R13 is on the interior, the R5 is on the exterior. And we'll show you pictures of this in a little bit. So when you get the math and you get the calculation, and if you look over to the far right, it'll say an R10 over 13. So this is a crawl space wall. So what you want to have is you want to have an R13 on the inside wall, and then you want to have an R10 on the exterior. So if you would have insulated your slab on that, or your foundation, you would have put an R10 exterior board on that outside slab or foundation, and then you would insulate the inside with an R13 to give you what you need to meet that code. New Mexico, we're in Zone 3. I think in all the time I've done any kind of work in New Mexico, I've only come across 3 basements or 3 crawl spaces. We handled those a little bit different back in those days. Basically used to lay a 6 mil visqueen on the ground for your vapor barrier, and then you insulated the perimeter with fiberglass insulation. I like that theory instead of doing floor. We'll talk about floors in a little bit. Again, mass walls, when we did our adobe wall, we're in Zone 3. We did mass walls. We did 18-inch block adobes at 1 inch per R value. So we got an 18-inch block, and then we put an R10 foam board around the outside, and then we wrapped it, black paper, stucco. So by the time we finished, we had about an R28, R30 on that wall. So, different ways of getting there. But these are the minimum requirements. Floor insulation, 13. You get an R38. It's going to be hard to make an R38 on your floor. You're going to have to use foam board plus insulation probably. Again, these are the minimum requirements. Okay, these are the examples that we showed you last time just to kind of put the picture to the checklist. Again, the one on the first top left, again, you can see that how the insulation is put in there. It's going to meet ResNet code. It has to be like this. It has to be smooth, evenly, so on. The one on the left, the most of the time that you get into a crawl space attic, it looks like this. Again, you look at the right one. The one on the right, the insulation's all over the place. It's crushed behind the wire. On the right side, the insulation has been split in half, so the wire is covered and runs through the insulation. It creates a smooth surface on the outside. Same thing down here. You can see all the different plumbing pipes. A lot of it isn't insulated. That whole area is compressed. Insulation is compressed. They just kind of stuffed it in there. And then on the next one, shows a good example of how that should look. They're not showing the same picture insulated before and after, but it shows a good picture of how it should look. Again, you're starting to see a lot of foams come on the market. You get these wet foams that go on wet and sprayed. You got to be real careful, make sure that whoever's doing that knows what they're doing, because that foam does expand and you could end up with a mess if it's not done right. The one on the left, you can see how it's done. A lot of voids, a lot of overspray, so on. The one on the right, on the top there, that really doesn't matter because that's going to be sheetrocked, so you won't be seeing that. That's a good job. And then we go into air barriers, fully aligned air barriers. Again, exterior surfaces, everything has to have an air barrier, exterior surface. So depending on climate 1 to 3, inside, and interior surface on climates 4 to 8. So this just says on your air barrier, the air barrier, again, the definition is anything that's going to keep the air from coming in to the conditioned area. We talk about barriers in the exterior attic and the eaves. What we're trying to do here is you want to put baffles in the attic. So when you spray that attic, remember we're talking about maybe up to 10 inches of insulation in these attics now. After you frame and you build that space in the attic, you're going to have an additional 10 inches. So what you're going to do, you might have a soffit vent in there, you might have a gable vent in there. What you need to do is you need to put these baffles over those vents. So when the wind or the vent is sucking air through there, it's not moving your insulation and it's not pushing the insulation away from the wall or from the insulated part. So these baffles are very important when you install them, and I'll show you a picture of these in just a few minutes. Again, all the exterior surface of the walls have to be insulated. We'll talk about the different insulations that you need to put on exterior walls. Again, depending on what climate zone you're in, that's the insulation or the R values you need to meet on the inside and also on the outside. Again, take into consideration, there are various techniques of doing other things besides this. You could go with an R13 inside, a blue board on the outside, and then you wrap it, and you get an R23 on that wall, R24. So again, there's different ways of reaching that. And if you're trying to meet just the minimum, it's a lot easier just to go above and beyond by adding a foam board, even if it's a 1-inch foam board on the outside. It's going to give you that little limit that says you exceeded the IECC 2009. So those are some of the things that you want to think about as you're doing this. Again, baffles, very important. Again, you want to prevent washing of the insulation into adjacent bays, and we'll talk about this. This is why you want the baffles in there, okay? So all the exterior walls and so on in climates 4 to 8 needs to have these baffles. I want to show you. Again, we'll talk about all the different walls. This list right here is the list that people find where HERS raters find the most problems when we go in to do an inspection. And the biggest place is the wall behind the shower and the tubs. You know, the plumber came in there before the insulators came in. He put in his tub, and it's done, you know. And there's no way of getting back there unless you're going to cut a hole or you're going to reframe that, or you're just going to take a chance that you're blowing insulation back there and it's settling there properly or whatever. But what should have happened before the contractor comes in to install that tub, you should have already sealed the base plate, the bottom plate. You should have sealed your corners. All that stuff should have been done, and the insulation in that corner should at least have been installed, if nowhere else in the house. Again, behind walls, behind fireplaces. You know, I've seen so many fireplaces where they're just, you know, once that fireplace isn't in use, you run an infrared camera in there, and that wall is just red with all the cold air coming in around that fireplace. You know, another theory behind fireplaces. You know, if you're in a room that's 80 degrees and you open that fireplace and you build a fire in that fireplace, the temperature in the room probably drops to about 72. So take that into consideration when you're putting in those fireplaces. They should be closed boxes. Attic knee walls. You get into these attic knee walls, nobody likes to get in there. Nobody likes to play in that crawl space, in that attic space with these knee walls. And we'll show you a few knee walls on how those should have been insulated. Again, it's in that pamphlet with all the footnotes. Skylights, we talked about skylights, what the U value should be, but we'll also talk about how you should insulate these skylights up in the attic. Because most of the time it's just a piece of sheetrock or something that takes that skylight from the roof to inside the house. Walls adjoining to the porch roof, we'll talk about these. Stairwells, double walls. Double walls, I don't see a lot of construction of double wall construction. To me, that's kind of expensive. You're doing a double wall. You usually have 6 to 10 inches in between the two walls. They fill that up with cellulose sometimes. The problem with cellulose, it has a tendency to settle over the years. So after about 10, 15 years, you're going to have this big void in that double wall, you know, where the second story sits on top of that. So again, double walls, you know, they do have their benefits. You can go with 2x4, 2x6 construction. They're quiet, you know, they're more enforced, they're well insulated, but again, it comes with its pros and cons. But, you know, I'll show you some double walls here in a while. The garage rim, band joists, we talked about this. We talked about this last time. Those band joists and those rim joists need to be insulated, whether they're insulated with fiberglass, foam, whatever it may be, but they also need to be sealed and caulked, and we'll talk about that later on. Okay, so walls, this is the picture out of that little pamphlet we sent you. Right in this area in here that shows it, this is the area that is being missed by most of the insulators, and it's right behind that bathtub. So what should have happened is your seal plate should have been caulked on the exterior. This should have been insulated, air barrier, and your tub could go in at that time. Again, you know, you can put rigid board back there, something just to hold that in place, or you can seal it with rigid board if you want, insulate it. You know, some people use rigid board in case it ever gets wet. Again, you want to seal all gaps, seams, and holes, you know, on that rigid board or the outside. So this is one, you know, that you'll always get caught if you don't watch it. Again, we talked about skylights. These skylights, again, you know, what you want to do with the skylight is usually sheetrock coming down. So what you want to do is you want to insulate that skylight, depending on what area or what region you're in. You know, I would just put a 4-inch or a 3-inch foam board on that, bead board, and then you can cover it with sheetrock and just seal that up. And again, you want to seal all the gaps, cracks, and stuff like that, anything like that. Because remember that skylight, that sheetrock's only 5/8 or 3/4. 5/8 or 3/8 sheetrock covering that light. Again, skylights, you got to work in the attic. So if you do it early, before you spray. Again, these are just some of the walls that we talked about last time. We talked about the different things on the top. It's not, you can see on the one on the left, the air barrier isn't connected, so it isn't continuous. The one on the right is a continuous air barrier. It goes all the way across. We talked about caulking everything, sealing all the penetrations. All the penetrations on that exterior wall or whatever that wall, that air barrier is going to be, you need to have it sealed. You don't want any air coming in, And we'll talk about air barriers and caulking, all that good stuff on part B of the session. This one down here on the left, I think they made a mistake. Air barrier is air sealed, but I don't think it's air sealed. I think it's open right there, and that's why they have the unhappy face. But on the right, you can see where they caulked everything. They either geocelled it or they caulked all the seams on top plates and bottom plates, under the windows, all the way around the windows. That's a good air barrier seal because there's no air and there's no penetrations, anything coming through there, Back in the good old days when I had a crew and they used to say, they used to hire us just to come in and do all the air sealing and caulking and everything. And I used to tell the kids that I had working for me, if there's a nail there and it's kind of loose, you think air's coming through it, caulk it. Caulk it. You want to seal everything coming in through that house. Because what's going to pay off in the long run is your blower door testing. And we'll talk about that. Again, the insulation on the right, you can see how it's back in there. It's not even with the 2x4s. It's smashed back in there. The one on the right is done correctly. It should be an even flow. It's continuously, you want to remember that word. It's a continuous level of insulation. It's a continuous run. And it sits on there all the way properly. You don't even see the 2x4s. All you see is the paper. Again, these are examples of what we talked about just a little bit ago. Again, floors, you want to talk about floors. You want a fully aligned air barrier of the floor above the garage. Cantilever floors, hopefully everybody knows what a cantilever floor is. These are floors that stick out above and beyond the foundation of the house. So you can sometimes walk underneath them, or people grow plants under there, but it sticks out beyond the foundation of the house, and it has space underneath from the ground to the floor. Okay. Floors above unconditioned basement and unconditioned crawl spaces. Again, we'll show you a little bit about floors. I don't know. I'm an old believer of foundations and crawl spaces. If you got a crawl space that's at least 3 feet high, you can get in there to work around. I would insulate the perimeter of the foundation instead of doing the floor, and we'll talk a little bit about that. Drop ceilings, soffits below unconditioned attics. Again, these are all other ceilings, and we'll show you examples of these. So the first one you see is there's no air barrier on this, and it doesn't continue back in there. This should have been sealed off right here at the far left corner. That should have been sealed off. So that soffit, here's one that is soft. It's blowing in with foam. It seals off that far end back in there. So when you're spraying your insulation, you're not filling that soffit with insulation. You're stopping right there over that 2x4. Again, the next one on the right, we talked about all the penetrations going through the attic or through the crawl space or the floor, whatever it may be. This particular case, we're talking floors. So this is plumbing insulation or plumbing pipes that are going up through the floor. All of them have been sealed. Again, no air penetrations coming in. The one on the left with the, I guess that's looks like an air conditioner dryer vent, I'm trying to say. And in there you can see where it hasn't been sealed. Again, on the lower left-hand side, you can see the insulation, how hasn't been installed. This is a floor. Again, you're looking up at this, so on the left, you can see where they just cut it, kind of stuffed it, You can tell people that don't like fiberglass falling in their face. But anyway, the one on the right, you can see how that sits in there just right. It's got what I call tiger teeth. It's a piece of wire that you can stick in between the joints, and it'll hold that fiberglass in place. Sometimes you can staple it. There's other ways, chicken wire, other ways that you can hold that insulation in place. One thing you want to remember when you're insulating floors is that you can't have any voids in the studs. So if your studs are 2 by 6 and the whole floor is 2 by 6, you need to put an R19 in there to fill that stud up with insulation all the way from the floor to the bottom of the stud. The problem with just putting an R11 in there or an R13, that insulation is going to drop down to whatever's holding it up, chicken wire, tiger teeth, whatever, and it's going to create a void between the insulation and the floor, and that's going to keep that floor cold. So you're doing all that for naught. So it has to be a full 6-inch insulation bat in there, hold in place. Again, perimeter insulation, it might work. You'd have to check with your rater. Let's see. So the one on the right, like I say, this is basically how the insulation is going to end up after about 4 or 5 years and nobody's gone down there and kept it up. The next time the rater or somebody goes in there looking at crawl space, the insulation is tiger teeth that fell, insulation has fell, all these voids are in place, and you can see where it's coming down. So on the right side, we don't have a good picture of that, but it should look like something like the one to the left. And it should be that way all the way around. Again, ceilings, depending on what area you're in, again, these are the minimum requirements for the zones. Whether you're going prescriptive or performance, you're still going to have to meet these minimum requirements. Okay. New Mexico, we have 3 zones in our area depending on what part of the state you live in. So, we have zone 3 through 5. Depending if you're in the southern zone, you only need an R30, the middle zone, R38, and so on. Again, if you're going to go with Energy Star, if you were in the zone 4, you're probably looking at least an R42 to bring that up to Energy Star or to exceed your minimum requirements. So again, depending on how much insulation you need, in our area, we're not trying to keep the heat in, we're trying to keep the heat out. So we do a lot of things different. We insulate the ceilings, we insulate the decking. We put foam board on top of the decking, below the decking, so all that heat is reflected back out. We use white shingles, those type of things. But then you get up into the northern area or the northern zone, zone 7, and you can see they need an R49. That's a minimum requirement of an R49. So you're looking at blowing in cellulose at 3.5. You're looking at about good 12 inches almost, if not more, 18 inches, just to get that insulation R value up there. So that's why I say when you're building these houses, you need to make sure that you have enough room to meet that minimum requirement, because they want you to have the continuous R value across that attic from wall to wall, top plate to top plate. Again, we were talking about the baffles in the attic. Right now, you're going to see where this baffle on the left is blocking all the insulation from getting back in there, and the wind is going to come in, but it's going to give you a void of insulation right in here because you're not able to cover it. The next one, you see where the baffle is above the insulation, so that's going to leave you space for that air. And all this is, what you need to think about this is just a cardboard piece that is stapled to this 2x4, and then it's stapled to this 2x4 on the bottom, and on the outside of this is a vent. So when that vent draws air, or it blows air through there, it's going to go up this baffle, and it's not moving the insulation around here. If you didn't have this here, every time that wind would blow, that insulation would blow all over the place, and after a while, you're going to have a void over each vent. The next picture on the right, that's a good baffle. You can see it leaves room for insulation, and also the air is far enough up where it's not going to bother the insulation. And you can see that by that blue line that they have up there. Again, these are only over the vents. If you have a continuous vent, then yeah, you're going to be doing every one. But if you just have soffit vents with a high-low ventilation, you could probably get by with maybe 10 of these. Again, depending in your area. So that's your time. That's your zones for insulation and your climate zone. So again, these are all in the books that we gave you, and it gives you the little page number on the side there. Reduce thermal bridging. Again, you want insulated ceilings with attic space above. For slabs on grade, climate 4 or higher, you want to insulate all those slabs. Insulate below the attic platforms. We'll show you pictures of these. And then reduce thermal bridging above grade walls, and we're going to talk about this. And there's various ways of doing the bridging. You got rigid insulation. These are basically your foam boards, your blue board, bead board, whatever it may be. You got your SIP panels, so structural insulated panels, insulated concrete forms, your ICFs. And here we talk about double wall framing, and I'll show you a picture of that and how that looks. And then we talk a little bit about advanced framing. And so again, this is what we're talking about for insulated attic space above non-cathedral ceilings and stuff. So you're looking at this area right in here. You want to insulate. Remember, the insulation has to be a continuous insulation or a continuous R value from top plate to top plate in that attic. So as you see the houses that were built years ago, they would start sloping that roof at a 312, a 112, or a 312, whatever, and you got that pitch at the very end. When you insulated that attic at the very end, you were making contact with the outside roof and the bottom, and you were probably only putting in about 3 inches of insulation over that top plate, if any. So, you probably had an R9 on the outside edge, and maybe you had an R38 in the middle, and it varies from there to the end. So now, when you build these houses and you're building your attic space, you want to make sure that you have enough room in the attic so you can have a continuous R value from top plate to top plate. So again, it gives you the R values, zone 1 through 5. You want to have an R value greater than, but or less than, not less than or greater than an R21. Zone 6 to 8, again, you got to have greater than, equal to, or greater than an R30. So if you're spraying an R30 minimum, you have to have at least a 10-inch space right there where that A is in that diagram. So in order to have an R30, you're going to have at least 10 inches or 12 inches of space. So you can't build the way we used to build and be able to meet that Energy Star or the performance measures anymore. Again, look at the footnotes. If I'm confusing you, you need a better explanation, you can look at the footnotes and it'll explain why we need to do the things that we do. Slabs, we talked about slab insulation. Anymore, we always insulate the slab insulation, and this is a proper way of insulating the slabs. Slabs should be insulated on the bottom, and they should be insulated on all sides, and they should come to the top of the cement slab, okay? Again, we're looking for slabs on grade, zones 4 and higher, 100% of the slab edge insulated equal to or greater than an R5, and a depth specified by the ECC. I think at this time it's about 2 feet that you have to do, depending on what your area, but the IECC calls for a 2-foot insulation barrier, thermal boundary. Again, this is something that has to be done. Anywhere in the country, I think you have to do it. I haven't been anywhere that they're not insulating slabs anymore. These are pictures of slabs. Again, talks about different zones that you're in. If you're in zone 1, they don't need to be insulated. Zone 2, either zone 3, you don't really have to, but according to the IECC 2009, you have to insulate your slabs all over now. So it's not something that you have a choice. Zone 3 in our area, you definitely have to insulate slabs. And from there on, it just goes on. The picture on the left with the unhappy face, you can see that the slab insulation doesn't exceed to the top of the slab, so it's not going to meet your Energy Star, and it's not going to meet your code either. One of the things that we did in comparing the codes with Energy Star and performance, that if you build to code, most of the time you're going to meet the minimum for Energy Star, and there's just a few things that you might have to tweak in order to make that unit meet Energy Star. Your windows are one, high energy efficient furnaces, some of those things, your overhangs, solar gain, those type of things you might be able to play with to get the Energy Star. The picture on the right, it shows how that foam board is all the way to the top. It's well insulated. It's even. The next picture to the right, you can see where the foam board doesn't go all the way to the top. It doesn't insulate that. So, and then on the next one, it just shows how it goes all the way. Talk about continuous wall. These are pretty simple things. Everybody's pretty much doing this. You will need to install these. We talked about the R values, you need to have an R value of 21 or 19 in your area. You usually go with an R13 on the inside, R10 on the outside. So this is something that's pretty common. And then we're going to talk about SIP panels. These are some of the ways that you can meet that continuous air barrier. Again, depending on the thickness of the SIP panel, is going to determine the R value that you have. SIP panels are great. They're a little more expensive, but the R value remains the same throughout the year or throughout its lifetime. Concrete or insulated concrete forms, same thing. These are all, poured in place and they're poured. Again, depending on the R value or the thickness of the foam, it's going to determine your R value. This is a double wall framing. I have never seen this done anywhere, maybe up north or northeast somewhere. But again, it has its benefits and it has its downfalls. Again, you got a double wall framing, you got two walls. This inside area, like I say, is usually sprayed with cellulose. The problem with that is they usually run all their plumbing, electrical, everything is run inside that wall. So if you ever get a plumbing leak or any kind of problems in there, it's going to be major. It's going to be a major cost to get in there and correct anything like that. Again, the only thing I see the benefits for this is double insulation, sound, reflects the sound. Again, I don't know. If anybody's building double wall framing houses, call me. Advanced framing, this is where we talked about advanced framing. There are some benefits to advanced framing. Some people don't believe in advanced framing. They say it's a waste of wood. Others say it's not a waste of wood. But either way, the advanced framing, you can see the difference. Most of these are OMB trusses that are put up here for the side walls. Same thing up here for the soffits. You got your OMB studs and stuff in here. Also your rafters, OMB rafters. So all this is usually 24-inch on center. It gives you a chance to go with a NART 19 wall. Same thing up here. You can go probably up to a NART 40 in these with 12-inch side walls up here. So it gives you that benefit. The thing with this is you're going to have to use probably a thicker sheetrock. Probably have to go with a 5/8 instead of a 3/8 sheetrock just because of the spacing of your 2x4s. Again, there's different things that you got to take care of. One of the things is your corners. What I call is a California corner. You need to make sure that those corners are framed in so you can insulate them. You can't have those three-sided corners anymore. What I call a California corner, it's easy to, just Google it, look it up. It's easy to do and it's easy to insulate. Along with advanced framing, benefits of advanced framing, pros and cons, be a good idea to look at that. Okay, I think that's pretty much it for Part A. Like I say, we'll break it down. I didn't want to do it all in one time because it's just too much to take in. But again, hopefully it helps you to understand what we're talking about or what the rater's talking about or whoever's talking about Energy Star and green building. I know if you're using any kind of home or rural development money, you have to start using these codes. Energy Star for any kind of shop money, HUD money, you're going to have to go to Energy Star. Again, here's some important websites. Our website, you got the Energy Star website, and you got the EPA, WaterSense, and the USGBC, and the Green Home Guide also. Again, there's some websites on YouTube that you can look at, and it talks about air sealing. I seen a real good one the other day about advanced framing, the pros and cons, and so on. So if you have a question now, I think we have like 10 minutes.
Yes, Gene. We actually have had some questions come in through the Q&A. We're going to quickly address those questions, and then we will move to open it up and unmute all the lines. But we would ask that folks that are not going to ask questions verbally, that if you would mute your lines locally so that we don't get all the noise and backfeed. That way other folks will be able to hear the actual questions and answers. So if you will go ahead and take care of that at this time. Jean, I'd like to give you the first question, or it's a combination question. Do you have any information on or guidance on size adjustment factors, or does the home size affect the minimum HERS index requirement?
Well, I don't have any information on that, but yes, the size of the home is going to adjust your HERS rating. I'm not sure the sizes anymore, but I know at one time a standard size house was like 1,800 square feet, and it went up to 3,000. So anything over 3,000 square feet or 2,800 square feet, I think you're going to run into issues with it dropping your HERS rating a little bit. But yeah, there is information out there in the size of the house, the location of the house, the situation, the way the house is situated. All those things come into play when you're coming into this, and we'll talk about a lot more of that as we get into that. But yeah, it does come into play.
The next question, do you know what the average cost is for meeting the standards of Energy Star 3.0 versus the savings?
Well, I think in order to, depending on what area you're in New Mexico, we did a study. We figured out it was about probably $15,000 more to bring that unit up to Energy Star. Rating coming in at a rating around 65 is what we shoot for. But again, depending on what you're doing and how you do it, again, we'll talk about some of these things that you can do to tweak your unit to be Energy Star and higher. So the savings that you're putting in, the money that you're putting in and the savings that you're getting back, we figured the average payback period would be about 7 years. But that's not talking windows. Windows, they go on forever. But you're going to start saving money, and you'll see money coming back within about a 7-year payback period. That's for New Mexico.
Okay, so the next question is, how do groups identify raters, or is there a specific listing or place to find or identify raters?
Well, we have a couple of raters that have lower door will travel, but, most of the time in our area, we only have 3 raters in New Mexico right now. Texas, I'm not sure about Texas. We have one in El Paso that kind of jumps the border back and forth between Texas and New Mexico. So our raters are booked solid, if you're going green, it's hard to find a rater that's going to be available. A lot of times what the raters will do, what we used to do, is we used to have them send us pictures or Skype us or whatever. Technology nowadays is great to where, you can actually do a walkthrough in a house with somebody walking around with a computer, showing you the walls, showing you the caulking, showing you all that stuff. So you're not wasting the HERS rater's time coming out there to look at your unit, and then he's sending you a checklist that's an arm long that you need to correct. So by looking at it before he gets there, he can tell you correct this, correct that, and by the time he gets out there, your checklist and your inspection will pass. Different parts of the country, I've heard everything from we don't have a rater in our state, we're paying $3,000 for a HERS rating, to we're paying $175 for a HERS rating. Those people that are paying $175, I really like to talk to them and see what their raters are doing. Because remember, your rater is going to have to come out there at least 3 to 5 times in order to do a good inspection on that unit, because he's going to have to inspect the framing, he's going to inspect the slab, he's going to inspect the framing, he's going to inspect the air leakage, insulation, and then he's going to do a blower test to see how tight it is, and then he's going to check all your furnaces, your duct systems, all that stuff. So by the time you get a HERS rater out there 4 or 5 times, it does get expensive if you only have 1 or 2 in the area. Recommendations, I have no recommendations for HERS raters because you can't, in different areas of the country, you can find them. In some areas, you can't find them. The governor of our state in New Mexico has done away with green building because he says it's too expensive and it's hurting the economy. So we're fighting with the governor now and trying to get all our USGBC back, all our green ratings, all that stuff back. So again, depending on what area you are, there's always, call Dale. He might know some raters in the east. The other one is...
Actually, Ben Bunker just provided some feedback, Jean. It's there in the Q&A.
Okay, and also Armin McNally also is another rater that you could call. But yeah, I don't have no recommendations there.
All right, and then the last question that we received via Q&A is, who or which particular entities require Energy Star 3.0? You mentioned some right as you were closing out, Gene, so can you just give us those?
Well, if you're using shop money or if you're using any kind of shop money from HUD, they require Energy Star 3.0. We're working with about probably, I would say 40, 50 groups throughout the country that are using shop monies through HAC, and some of them are able to meet the Energy Star 3.0 easily. Others are having problems finding raters to come out and rate the units. So, I know that's one of the things that's in front of Congress right now, and some of the things that are being discussed is how Energy Star and SHOP are working together. It's kind of strange, but they did bring that up. Again, it all depends. But like I say, if you build to code, you're almost there. It's just a few tweaking that you might have to do, and you can meet Energy Star.
All right, with no questions coming forward, I'd like to thank Gene for his presentation today. I'd also like to thank all of you for joining us on the call today. Gene, do you have any last-minute comments that you'd like to share?
No, just hopefully this sinks in a little bit. It makes it a little bit easier for you to understand. Like I said, we try to develop it so it's anybody that has anything to do with housing, from the packager to the construction supervisor to anybody, the accountant can understand it. Again, there's my contact information on the screen. If you need me, give me a call, and hopefully you can attend all 4 workshops or webinars that we're having. Next time, we'll be talking about air barriers and air leakage, and that's what really determines whether your blower door test is going to pay off or not, and that's when you air leakage. All right, thank you.
All right, so thanks again, everyone. You will be receiving an email following the webinar with evaluation requests, and so if you would, please help us out and complete those evaluations. Gene's number is on the screen, and if you have any questions, please contact Gene or myself. We're more than happy to assist, and enjoy the rest of your day. Thank you.